IQ then, it is. All right. So you all drew your very best normal distribution. We're going to start labeling it. So here's mine. It'll work. The mean, if we're talking about IQ, is what again? 100, okay. Standard deviation is 15. So I'll put a little note up here, sigma equals 15. So then I'm going to label, what is one standard deviation to the right? 115. And what is two standard deviations to the right? 130. Oops, let's write that down here. And then let's go to the left. 85 is 1 to the left. And 70 is 1 before that. Oops, that's a 5. I think I need to resync my board. Oops, come on. There we go. All right. Next, what are z-scores? Sort of measured with what ruler? What's the ruler that z-scores represent? What do they count for us? They count standard deviations, yeah. So here I made a ruler where each unit is 15, right? Let's see, I got one more to make. 70, that's better. Oops, but I want to write it lower. Wouldn't it also be accurate to say that the mean is in the middle, 0? There's 115 is 1 standard deviation to the right. 130 is 2 standard deviations to the right. So the z-score for 130 is what? 2. It is exactly 2. Yes. Okay. What's the z-score for 85? -1. It's 1 to the left. And what's the z-score for 70? -2. Okay. So we can jump back and forth, and the book does this and the homework does this, between z-scores and actual measurements. Whether that measurement's a temperature or an IQ, it doesn't matter. How do we calculate z-scores? Yeah, x minus mean divided by standard deviation. That is a z-score. Okay? Excellent. So let's suppose that I have a z-score. Gary's z-score, oh my gosh, is 0.1. Based on my z-score, can we figure out what my IQ is? Yeah, right? We just, well, careful. We have to think about this formula right here. So I know that my z-score is 0.1. I don't know what my x is. My x is my IQ, but I do know the mean is what? 100, and the standard deviation is 15. So that means I'm 1/10 of a standard deviation below. What's 1/10 of 15? Yeah, wouldn't you agree to solve for x would multiply the 15 up? Yeah, so that gives me 1.5, and then I would add the 100 over, agreed? So my x value must be 101.5. So what is if I wrote that as a formula, given my z-score, I multiply it by the standard deviation, and I add that to the mean. This is how you calculate an x value given a z-score. This is how you calculate a z-score given an x value. You can go back and forth between the formulas. Do you really have to memorize both formulas? No. You got to memorize the top one, and you can use it to go backwards. Just a little bit of algebra. Okay. Next question. What is the probability that somebody has an IQ score of exactly 101.5? You don't even need your calculator for this. Lewis? 0. Yeah, there's infinitely many possible IQ scores. 1 out of infinity is nothing. Sample size is too big. One individual measurement in a continuous distribution is always 0 probability. I could ask a different question. I could say, well, what % of people have an IQ score that's less than or equal to Gary's? I can draw a picture of that. Is my IQ score close to the mean? Yeah, here's the mean, that's 100. My IQ score is pretty darn close. It's just barely above average, right about there. So this question right here says, what is the area in the left tail? Yeah, and the calculator is a button that does exactly that. On the calculator, this probability is the norm dist, is that what it's called? Or am I thinking of Excel? I'm getting all these computers. Oh, it's normal CDF, right? Yeah, Excel is a little different. Norm CDF, or is it normal CDF? All right, way too many pieces of technology. Normal CDF. And normal CDF wants to know, let's see, the X value first. Lower than upper. Oh my gosh, I got to look at my notes. All right, let's see. I had to write notes down because there's too many pieces of technology. So it's not a web browser. Where's my web browser? How many people don't use the TI very much? Or does everybody here use the TI? Don't use the TI. You don't use it very much? Okay, so if you're not using the TI, then you have to know what to type into your other technology. So I made a summary. I'll post this summary on our websites. Okay, normal distributions. So if we're doing left tails, that's down here. Okay, so the TI, okay, there we go. Left side, right side, mean, standard deviation. If I were doing this on Google Drive or Microsoft Excel, there's a slightly different formula for those. And I will post all these formulas on the course website in an announcement. So on Excel, I would say norm dist. I want to go up to 101.5, mean and standard deviation. We're all going to type pretty much this formula right here. Normal CDF. Okay, now the normal CDF, I have to go to the left forever. What's the calculator's version of negative infinity? Yeah, -1 E99. So let's bring up the calculator. I need a bigger display for my calculator. Let's see, second variables, normal CDF. Are we ever going to use the normal PDF? No, never, ever, ever. Normal CDF. Okay, left side is negative. The E is located above the comma on your TIs. It says EE, but it really gives you the E, which is the engineering times 10 to the power. Upper bound here is 101.5. Mean is what here? 100, thank you. Standard deviation is 15. So if you have an older version of the calculator, you're just typing those numbers. Left bound, comma, right bound, comma, mean, comma, standard deviation. Enter, and we should find it's just over 50%, because I'm just to the right of the mean. So I get 54.0% if I'm going to the nearest tenth of a percent. So -1, little e, that e. Oh, by the way, see how this is a capital E? That scripty E? Different idea. Did you find your E? Question? You getting a different number? You forgot your lower bound. First, you got to do the -1 E99. So you got to tell the calculator what's the left. So the normal thing always works. What's the left number? What's the right number? My left number is negative infinity, essentially. My right number is 101.5. And then you give it mean, standard deviation. You have always four numbers. Always, always, always four numbers. 101.5. 115, okay? And I calculated, rounding to the nearest tenth of a percent, that it is 54.0% if I round to the nearest tenth of a percent. Agreed? Is everyone getting that same number? We all need to be able to get these buttons and push. So if this problem came up on the test, I would expect to see exactly what you typed in. You need to write that down for me. Any tests, any quizzes, I need to know what you typed. I always draw pictures too to make sure I'm getting it right in my head what the heck I'm supposed to be calculating. All right, let's do a different one. let's suppose I want to know what is the probability that a particular IQ score is between 75 and 105. So first, draw a picture of what that looks like. Draw the normal distribution. Here's my normal distribution. I've got my other one as a reference. Mean is 100. So 1 standard deviation, 2 standard deviations. What was 2 standard deviations below again? It was 70. So I'm a little higher than that. Oops. So 75 is maybe right here. And then on the other side, 1 standard deviation to the right is 115. I'm only going to 105, so that's about maybe right there, perhaps. And so I want to find what is this area in between there. Okay, what do you type on the calculator? Give it a shot, and let's see if we get the same numbers. All right, so remember, TI, left, right, mean, standard deviation. By the way, if we were doing this on Excel, for those of you who like spreadsheets, that's what I typically do. It would be norm dot dist, and then it's, what did I say, x value first, mean standard deviation. Yeah, x value mean standard deviation. Which makes it a little bit trickier on Excel. Because we're not, you only do that if you're going to the left forever. We're starting at 75 and going to 105, yeah. So you only, if you have a tail on the left, you'd have negative 1 E99. What if we had the tail on the right? What would our right-hand bound be? Positive 1 E99. Yeah, we'll do that one next. Okay. What do you get? About 58%? Okay, on a good day. Let's check if we're having a good day. Oops, mine just went off. I can just do the augment the previous one. Okay, so I want my right bound and my left bound. So instead of negative 1 E99, I have 75, comma, my comma. Then I have, what was it, 105? And then comma, and let's delete the extra stuff. Oops, a couple extras there still. Enter. Yeah, 58.3%. If we went to the nearest tenth of a percent. And the online homework, sometimes they tell you to go to 4 decimal places as a decimal. Sometimes they tell you to round it to a percent. It kind of depends. So 58 point, help me again, 4? 3? Okay. All right, let's do another one. So that means 58.3% of people have IQ scores between 75 and 105. Hey, what would the z-scores for 75 and 105 be? So negative 1 point something? Let's figure out exactly what it is. I'm kind of curious. So on my calculator, I'd go parentheses 75 minus the mean 100, close parentheses, divide by 15. So the z-score there is negative 1.66666666. So negative 1 2/3. What's the z-score for 105? 0.33333333 maybe? Anyone figure it out yet? oops, that should be a 5. Oh, lucky guess. 0.333333 is the z-score for 105. Which I could call 1/3 if I want. So if I ask this question, what percent of people have IQs whose z-score is between 1.67 below and 0.33 above the mean? About 58.3%. It doesn't matter whether you refer to the z-score or whether you refer to the actual score. Anyone ever take tests like the SATs, or maybe you're going to go to school, you take another test? Anyone going to be a teacher maybe? You have to take lots of tests. They often rank you with z-scores on those tests in addition to percentiles. Let's talk about percentile rank. Remember we did percentiles before? What does P90 mean? 90th percentile? What's that? My mother's like, what the hell's 90th percentile, Gary? Excellent. 90th percentile. Yeah. So 90% are at or below whatever that skewer is. 90% are at or below that value. Which value? I don't know. See if we can figure that out. Draw a normal distribution. Question. The mean is 100, right? What percent of the population is at or below a score of 100? What percent of the population is at or below the mean? 50%. It's the mean. It's the middle. Yeah, 50% are at or below. So I think that some IQ score out here, I don't know which IQ score, represents a score such that 90%, right? So the area is the probability. I want to find that score. That's backwards of what we're doing. We've been starting with IQ scores and calculating probabilities. I want to go the other way. When you reverse things in math, that's called inverting them. So to do this particular problem, we need what's called the inverse normal. The inverse normal gives you one of two things. It gives you z-scores or actual values. So write this down. INV norm means inverse normal. And what it does is, given a probability in the left tail only, it outputs either z-scores or actual values. In this case, an actual value would mean an IQ score. If we were playing with temperature problems, it would output a temperature. And the way it goes is the percent in the tail, the mean, the standard deviation. So if we want to know what IQ score marks the 90th percentile, then that means I would use inverse norm. P is 90%, so 0.9. Mu is 100, sigma is 15, and we see what it gives out. What is it? 119.22? Approximately 119.22. Let's all make sure we can come up with that number and see if it's reasonable by looking back at the picture, because it's easy to push a wrong button. I do it all the time. And we better stop after this example. Let's see, option 3 is inverse normal. Area is 0.9. By the way, whether you're using Google spreadsheets, Excel, Apple's numbers, it's the same formula. Oops, 0.9, oh shit, what'd I do? 0.9. Now, if I wanted z-scores, I would go for 0 and 1, because the mean for z-scores is 0, standard deviation is 1. But I want IQ scores, so that's 115. So it's going to be inverse norm, 0.9, 115, enter, and we get the 119.22. All right, is that reasonable? Let's look back at this picture right here. That would put me right about here, I think, or maybe over a little bit more. You think it's reasonable? That's about the 90th percentile, P90? Probably. Looks right. Yeah. How could we check it? We could do the normal CDF from negative infinity all the way up to 119 point blah, 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 and see if it comes out to about 90%. If it does, we nailed it. So we can go back and forth with these. Okay, so material we've been covering here is up through 6.3. We are skipping 6.4, and on Monday we will start 6.5, which is the most amazing idea in mathematics ever. I was telling my mom at the river, and she was pretty impressed with it when we were talking this morning. Oh, extra credit, extra credit. Everyone know what the extra credit assignment is? Okay, so you see how I use the computer to draw a binomial distribution? I would like you to use a piece of software to generate a histogram that represents a binomial distribution. And you will get extra credit for doing that. You have a week to do so. I will help you if you need help. So I want you to use a piece of technology to draw a binomial histogram. That's the extra credit. Oh shit, yeah.